All right, algebra students, we are ready to take a page of notes, and so we're on page 9 in our notebook, and we're going to review something that you learned last year, but we're just going to make sure we have it in our notebook. We're going to streamline it, make sure we understand all the steps, and practice it before we move even further into this unit. So you've already taken your Unit 1 test. This page of notes actually begins Unit number 2, which is entitled Equations. So, of course, all of the assignments after the unit test that you just took yesterday are going to be under Unit 2 equations. So we're out of the Unit 1 folder, expressions, and now we're going to be dealing with equations. And so the very first thing we're going to talk about in our unit on equations is actually solving multi-step equations. Again, you solved equations last year, but we just want to make sure that we can solve some multi-step ones, some ones that take multiple steps to solve. And so remember, the goal of solving an equation is always to solve for the variable, right? The end goal is always to find out what is x equal to, or what is h equal to, or what is m equal to, or whatever the variable might be. And in order to solve that, we're going to follow a few steps. And I remember these steps. These are the steps for solving a multi-step equation. I remember them because it's the first 4 letters of the alphabet backwards. So not everybody teaches it like this. This is just how I remember. So we're going to call it D, C, B, A, as in the backwards A, B, C, D. And then we're going to start D, C, B, A. And so what do these things actually mean? Well, step number 1 is going to be the D, and that stands for distribute. We're going to distribute if you can. Not all the time are we going to have a distribution step. So first step is to distribute. That's only if you can distribute. And remember, distribution, we're talking about like a number sitting outside of a set of parentheses where we're going to distribute, 3 times x, and then we're also going to distribute 3 times 8. And so that's what I mean by distributive property. The letter C, and that's going to be step 2, stands for combine like terms. And again, this is an if you can step. It's not always going to be possible. But by combining like terms, I mean if you have something like 5x plus 2x, we're going to go ahead and say that that is 7x's, right? If you have 5x plus 2 more x's, that's 7x's. And so if you can combine like terms, then you should go ahead and do that. That goes for numbers as well. If you have the numbers 5 plus 2, you should go ahead and combine them to be 7. The B step stands for bring variable to each, or to one, not each, to one side. Bring the variables to one side. And it's another if you can step. I'm not going to write that in. But bring the variables to one side. That means if you have an equation where you have, let's say, 3x plus 1 on this side, and you also have an x over here, so you've got this x and this x, we need to make sure that those x's are on the same side. We want to make sure that we can't solve if x is over here and x is over here. We're going to want to either move this x onto this side or move this x onto this side, and we'll do an example of that in a minute. And then step 4, of course, is always solve. Like, just you have to solve the equation after all is said and done. Always solve. And of course, by solving, we mean x is equal to something. Like we want our variable by itself, solve for the variable, and we want a number over here. So we want to know what is that variable equal to. And so we're going to do a few examples using these steps. And so we're actually going to do 1, 2, 3, 4. We're going to do 5 examples. So if you want to take the rest of this page here and maybe just split it in half for right now. And that way we can use our space wisely, and we can also have an example on either side depending on how long they go. So let's call this example number 1, and I'm going to start with an equation that looks like this. 10n plus 3n plus 7 is equal to 202. And so we remember that when we're solving equations, of course, our goal here is to get n by itself. We want to know what is n equal to. And we're going to follow the steps above. Now, one step I did not write in here, and you probably have already done, is we want to draw a line down through our equal sign because that's our balancing point, right? If something is equal, we want to make sure that we're keeping this side separate from this side because this side is equal to this side. So I always draw my line down through my equal side, and then we follow the steps. So distribute if you can. Do we see any parentheses like this that we're able to distribute in? No, there's no distributing here, so step 1 is done. Combine like terms. Do we see terms that have variables or numbers that we can combine? And when we're combining like terms in this step, we want to make sure we're looking at one side at a time. So ignore the 202 for a second and just look on this side. Absolutely, we have like terms. It's the n's. And so we're going to go ahead and do 10n plus 3n, which is down below here, going to give us 13n. Try to keep everything nice and lined up, organized. We're going to bring down the plus 7. And then we want to bring down the 202. All right, so we have combined like terms. Do we need to bring variables to one side? So do we have like an x on one side and an x on the other? Well, if we look on this side, we do have an n. Is there an n over here? There is not. So the b step is also already done. So now we're ready to just solve like normal. And so remember, our normal steps is we want to look at the variable and get the furthest thing away from the variable on the same side as it away from it. So right now n is attached to 13 and n is attached to plus 7. So I'm going to get rid of the plus 7 because the 13 is closer. So I'm going to subtract 7 from each side. 202 minus 7, you can type that in Desmos, gives me 195 is equal to 13n on this side because the 7's cancel. And of course the last step is these are attached with multiplication, so I'm going to divide. 195 divided by 13. 13 divided by 13 cancels, and we're left with n, which is good. That's our goal, is to get the variable by itself. But 195 divided by 13, again, you can type that in your calculator, is 15. And so my final answer is n is equal to 15. So that is one example of how these equations work. You might see another example might look like this. So we have negative 14 is equal to 2 times k plus 5 minus 4. And so again, we're going to use our steps to solve this problem. We look first and we draw our line down the middle through the equal sign so that we can split up our sides, and we look for distribution first. Now this one we do have a set of parentheses, so we are going to distribute the 2. Negative 14 stays on this side. We've got 2 times k, which is 2k, 2 times 5, which is 10, and then the 4, of course, is not in parentheses, so it just goes along for the right. We don't need to distribute the 2 over here to the 4. We've distributed. Next step is combining like terms. There's nothing to combine on this side. It's just 14, but we do have something to combine over here, and it's just these plain numbers. So we have plus 10 minus 4, and that is going to leave us with negative 14 on this side, 2k, 10, positive 10. Notice take the sign in front of it, positive 10, take away 4, gives me a positive 6, and so I'm going to leave it as plus 6. Be real careful with the signs here. If you come out with a positive answer, it's plus. If you come up with a negative answer, it's minus. All right, we've combined like terms. Do we need to bring the variables to one side? Well, no. There's a k over here, not a k on this side. So we have already brought the variables to one side, and so we are ready to solve. And so with the k, first thing I'm going to do is take away 6. Take away 6 from each side. That cancels. Negative 14 minus 6 is going to give me negative 20. And where that's equal to, we have 2k left on this side. Divide by 2, and we get k is equal to negative 20 divided by 2 is negative 10. And so my answer is negative 10. Okay. All right. So let's go ahead and chop off those examples. And we're going to do example number 3 down below here. Remember, we want room for 5 examples. I hope we'll be able to fit them on here. So example number 3 is going to be a problem that looks like this. We've got 4 minus 3, and then x plus 3, in parentheses is equal to negative 32. So again, same process, right? So we look back up here at the top. First step is to distribute. Now, we have to be careful. This is why I threw this example in here. We have to be careful about what we are distributing. So we do have a set of parentheses here, and it's being multiplied by what? What is out in front of the parentheses? It's a 3, but actually we have to treat it like it's a negative 3 because there is that minus sign in front of it. So we are actually going to distribute negative 3 to everything inside this set of parentheses. So in this case, we're going to start with 4. Negative 3 times x is negative 3x, so we're going to let that be minus 3x. Negative 3 times positive 3 gives me negative 9. And so again, I'm distributing the negative 3, not just a 3. Be careful if there's a minus in front of it, and that's going to be equal to negative 32. All right, so that was distributive property. Remember, the next step is the C. So that's combining like terms. And of course, I did not draw my equal sign. There we go. Combining like terms. Do we have anything to combine? Not on this side, but we do on this side because we have a number, two numbers, and 4 minus 9 gives me negative 5. So I'm going to write down negative 5. And of course, again, remember the sign goes, the number, and the sign goes with the number that is in front of it. So 3, we have to take that negative. So this is going to be negative 3x is equal to, and we've got negative 32 on this side. We don't have to bring the variable to one side. We'll do that in the next example. X is already by itself on one side, so we're ready to always solve. To get rid of this 5, we're going to add 5 because it's a negative 5 to make it 0 to get rid of it. So we're going to add 5 over here, and we've got negative 32 plus 5. Type that in your calculator. You get negative 27 is equal to, again, be real careful here because there's a negative in front here. We have to bring down the negative 3x. And so eventually we are dividing by negative 3, and that cancels. And so we're left with x is equal to negative 27 divided by 3. Well, 27 divided by 3 is 9, and it is positive because a negative divided by a negative is a positive. All right, the last example I want to do, I said we were going to do 5, but we're definitely going to run out of space. So I'm going to squeeze these last two examples together into just maybe one giant problem. If you can work example 4, you can probably do all of this. So let's do this. We're going to do 5 minus, and in parentheses, x minus 8 is equal to 7x minus 5. All right, and so again, we're following this DCBA method. So D stands for distribute. I see some parentheses. I'm going to have to distribute. What is there actually outside of these parentheses that we can't actually see here? Anytime we don't see something, there's a 1 sitting in front of there. And it's not just any old 1. Just like over here in the 3, the thing that we are going to be distributing here is not just 1, but it's negative 1. So that's my first step, is I'm going to distribute the negative in front of the parentheses, which was really a negative 1. So I'm going to bring down my 5. Negative 1 times x is negative x, and negative 1 times minus 8, or think of that as a negative 8, negative 1 times negative 8 is a positive 8. That's going to be equal to, on this side, we still have 7x minus 5. The distributive property, done. Next step is combining like terms if you can. I'm going to draw my line down the middle. I keep forgetting to do that. Combine like terms if you can. So, do we have any like terms to combine on this side? We do. We have a 5, and we have a plus 8. 5 plus 8 gives me 13, and then we still have a minus x. Make sure you take that minus with it. Is equal to, on this side, we're still dealing with 7 minus x. Combining like terms, done, because there's nothing to combine over here. This one has an x, this one has a 5. Next step is to bring the variables to one side. So now, we do have to do this in this case. We have a minus x over here, and we have a 7x. It does not matter whether you, and I'm going to use a blank sheet of paper here. You don't have to write this down yet, just watch. It does not matter if you want to bring the 7x over here. You would subtract 7x from each side, and you would get negative, there's really a 1 there, remember, negative 1 minus 7 gives me negative 8x. You'd end up with a negative 8x on this side. This would cancel. Or it does not matter if you instead want to bring this x over here, in which case you would add 1x to this side, thus canceling this, and you'd add 1x to this side and end up with 8. Now, I tend to like positive numbers, so I'm actually going to do this method, and I'm going to bring the x over here. But again, bringing the variable to one side, it doesn't matter which side, as long as we no longer have x's on both sides. So I'm going to add 1x just to keep everything positive. That's going to cancel. I'm going to be left with 13 on this side. 7x plus 1x gives me 8x minus 5. The next step is going to be to add 5 to each side. Add 5. 13 plus 5 gives me 18. And I have 8x on this side, so my last step is to divide by 8. 18 divided by 8 does not go evenly, of course, but it does give you the decimal 2.25 is equal to x. Don't be afraid of getting decimals. I actually think on your quizzes practice that there's not any decimal answers, but it is absolutely positively okay to get a decimal answer for a equation. And so those are the steps, and that is the process for solving multi-step equations. Again, this is a lot of review from last year, but we need to make sure we're good at this before we move forward in this unit. So your quizzes is going to be practicing this method. Remember, you can take the quizzes as many times as you'd like. And if you need any help, make sure you email me.